All right, so our next panel is titled Encryption Endeavors, and it's titled this way because there are different ways and methods of encryption that can be used. In crypto community, most of the people are by now familiar with ZKs, standing for, is it working, the mic? Yeah, it's okay. Standing for zero knowledge proof, but there are more tools and more methods that can be used to achieve encryption. Finally, this is the main purpose, of all these technologies, but you will hear about other usages as well. So to kick off this panel, I think it would be wise to put some primer on the subject. So we have with us today 3 very impressive founders, all coming from different fields, relatively speaking, and they will cover different topics. So we have Avishai with us, who will cover more on the technical side. We have Anish with us, who will be talking more about privacy, and Lasha, who will give us more inputs about identity management today. All 3 are well familiar and a long time in this field. So let's kick off with Avishai. And Avishai, you gave me already a very good primer once on another panel, explaining to audience how all these technologies are related, that basically ZKP, zero knowledge proof, is just one child of one big and happy family called MPC, multi-party computation. Can you expand on that?
Hi. Hi, everyone. My take here is that, probably people heard about the term MPC for, in many contexts. Probably the most familiar context of MPC is instead of using TSS, which is threshold signature scheme. So most of the usage right now of MPC is for multi-party who wants to sign together using a shared cryptographic key. So they want to send only one signed transaction on chain. But actually, MPC is for much larger functionality. MPC gives you the ability to do any kind of computation between many parties, where each party that can be either individual or a company, enterprise, whatever, that has sensitive information that it doesn't want to reveal. And then you want those parties, they want to get an insight about those combined sensitive information of everyone, but without revealing the actual sensitive information. So you can think about maybe two-party example where you have your DNA in a digital form, and there is some healthcare company that can analyze your DNA, and you want to give them the DNA to analyze, but on the other hand, you don't want to give them your DNA and still get the insights. So if you have a high potential, high risk for some disease, you want to know about it, but you don't want them to know about it. So they have the algorithm, you have the data, and you want to do some computation together. This is an example for two-party computation, but you can think of multi-party computation. Let's say you want to contribute your DNA to a much larger computation with a lot of other people, and then get some statistics about where you are on the scale of risk for some disease. You can do this for financial data as well, like to check how much do you spend related to big population or any other case. So this is the problem, the name of the problem. Multi-party computation is the name of the problem, and there are many solutions for this problem. In the industry, or actually in the literature, there are 3 main approaches to solve that problem. One of them is called fully homomorphic encryption, which is a type of encryption that gives you the ability to do computation on the encrypted data. So the encryption itself retains some of the structure of the underlying data. The second is called garbled circuits, which is a technology that we developed in Solar Labs. And the third one is called secret sharing, which is also underneath the signature schemes that people are using today.
Thank you. So going to you, Anish. So you have been working on privacy field for quite a while. You're the founder of Panther Protocol. It's not so obvious for many people. Why do we talk about privacy when it comes to encryption? Some people think that actually privacy, some kind of, in a way, is included in encryption. There's some kind of secrecy. Can you elaborate on that?
Oh, it's kind of trivial. I was just about to add something. So generally speaking, the classic problems that everybody in MPC would talk about when you have multi-party is a millionaire's problem. So a bunch of millionaires who sat around wants to prove to somebody that somebody has more money than anybody else without really revealing how much each of them have. So the thing I want to describe is like cryptography, typically encryption and decryption means like you have one adversary. The adversary can't read what it is. But privacy doesn't mean that. I'll give you a very simple example. So, if you have a room and, there's just one occupant in the room, the person who goes out, whether they wear clothes or without clothes or cover their face or not cover their face, right? You can think of covering the face as a representation of encryption, right? So like everybody coming in, if they encrypt, their face is masked, they wear a mask, right? But if it's just one person, even if they encrypt it, you pretty much know that that's the person, so you have no privacy. So if you want to get privacy, you need to have a privacy set. So if this room has 10,000 people, your ability to guess who the person wearing a mask leaving is going to be 1 in 10,000. So that's literally what it means.
Thank you. So if there's one field that we really want to have some privacy, it's definitely linked to identity. And this is the segue to you, Lasha.
True, yeah. How identity and privacy works together is similar to the DNA model, because I guess DNA is our identity at its basic level. And the idea here is that identity has this kind of waves of evolution that catches up and adopts a certain technology primitives, and that gets reinvented. And unfortunately, we haven't seen a quite scalable, globally working system so far, because mostly all the innovation within the identity space has been driven from top down. The reason for that is that our basic identities, such as who we are, our name, our age, our citizenship, everything is issued by the governments and tested by the government. So all the evolution and research mostly has been done through this top-down approach. Actually, the latest trend and the zero-knowledge proof application within the identity to preserve privacy, I'd say is this kind of new field and new opportunity field that opened up for different companies to experiment and adopt identity natively within their systems and not rely on the external government-led databases or system-wise. How does identity work? So you can have a certain attribute of yours, you can take certain data from the passport and being able to verify the correctness or the certain idea that, for example, you're over 18 without disclosing the
actual age.
Yeah, actual age. But I think there's one little enhancement we need from an identity systems, and that has been not treated yet because technology-wise and zero-knowledge proof-wise we're not there. Most of the time we run into limitations that, well, I believe that we should not rely on NPC or external services for the identity information, such as your face, for example, or your age, or anything to be shared and processed on their side. But for the identity to work and scale, for me, it's client-side proving. That means that you can use solely your mobile phone, run the entire algorithm on your device, and being able to tap a passport, prove your age, take a selfie, prove your liveness, your uniqueness, and build up its most distributed and fragmented network, not fragmented, but like distributed network of identity working directly on the devices the right way.
Interesting, thank you. So next round would be to expand on what you guys are working on right now. So Abhishai, I know that you are doing, from what I have seen, the first implementation of garbled circuits in crypto. So how did you choose to do, because you are familiar with the family, so you had many options and you're a long time in this field. How did you choose garbled circuits?
Right, so we started to build a solution based on garbled circuits, which is one type of solution for MPC about 1.5 years ago. And now it's already live and passed security audit. And we have a background in MPC, and we explored the possible solutions, and we saw what can be done with FHE and with secret sharing, which are kind of two extremes of solutions to the problem, because in FHE you can do all the computation alone, and in secret sharing you need always to interact with the other parties. And garbled circuit is somewhere in between, where you can do a lot of computation alone, but after some pre-processing phase that you did that is independent of what you need to do in real time. So this is exactly what we do. The parties, they prepare a lot of cryptographic information offline all the time, and then they are prepared to whatever computation that they will need to do in real time. And then in real time, they have all the cryptographic information to use to do a lot of computation in a very short time. So they can be prepared to peak throughput demand. And this is why we chose garbled circuits. In the literature, garbled circuit is known as the fastest form of MPC. It has its limitation because there is some pre-processing phase need to be done, and this pre-processing phase requires some bandwidth on the network. So this is why people were kind of afraid of touching this, but we made it possible to be used on chain. And people always mention FHE as maybe the holy grail of cryptography. Maybe you heard this term, because it combines encryption, which is a form of making data look like garbage, but on the other hand, it makes it usable, so it's not like garbage. But what I'm arguing is that using garbled circuits is even holier than that, because it not only invents new type of encryption, it actually using the existing type of encryption, most prevalent on the internet, which is AES, and make this type of encryption homomorphic and being able to use it with computation.
Thank you. Anish, you have been working in the field for a while, and we have noticed in the last several months, I mean, the trend started earlier, that there was a big decline in users among the ZK projects. I mean, even ZK Sync, that was one of the most prominent and used projects. Of course, Scroll, and we see the pivot of Starkware into Bitcoin, and a few others. So what are the use cases that you think are still valid? And what can you tell us about this trend?
So I probably will have to touch upon what the previous speaker was saying. So I just want to make sure that everybody's on the same page. So essentially, if you look at garbled circuits, CL was the earliest of the cryptographic primitives. If you think about ZK came after that. FHE, it only happened in 2008. Craig Gentry, that's his PhD thesis. So in the sense of speaking, for adoption, things take a bit of time. So AES, so I'm one of the guys who wrote the test vectors for that. CBC mode, I wrote the test vector. So it takes like a real long time for various things to be adopted. And in terms of ZK, what has happened is like there's always this hype cycle. So ZK went through the hype cycle, and now people are recognizing, the hype is over, there is some cost involved. So ZK is not free. Nothing in cryptography is free, let's be very honest. There is no MPC that's free. So, there's a trade-off between complexity and computation. It's like you can pre-compute and store, or you have to have compute and you do it. So you draw the line. So in terms of ZK, you have to do the stuff when you have to do it. Okay, so if you want to say have an AMM with privacy and you want to use ZK, effectively what that means is you have two kinds of losses. One loss is the fact that when you do batching, instead of having a instantaneous price discovery, you have a batch and you do a price discovery, which is an average. So that's a loss. So you have two curves, the curve that's the actual instantaneous price and the price that's a linear part of the curve and a curve part of the curve. Plus, there's the cost of doing ZK in that sense. Plus, the other bit is like, because of the various choices that the L1s and L2s have made, throughput you have in various places are very different, and you pay different costs for it. So if you look all of this and you look at it and you go, people generally don't care as much as they should about privacy. So add all these things together and you say wherever we are with ZK.
Thank you. Lasha.
It was not that positive, right? That's what I felt.
Yeah. Anish always brings up the costs, I have to confirm. We have heard this before, but it remains the issue. So, question to you, Lasha. One of the latest developments that is related to identity is a project called WorldCoin, which is supposed to go live sometimes very soon, if not tomorrow.
It's live.
It's live already?
Yes.
Okay, I saw the VCs not canceling token 2049, heading to San Francisco to support them. Moral support. So, there are mixed opinions in the community about this project. So, please share yours.
Yeah, I think
he said he can handle it, so it was a light.
Okay, let me start. Let me start from the beginning. We have time, right?
Please.
So basically, it's live. You can go and scan your iris and prove your uniqueness. The entire idea behind this type of new identifier, it's about the proving your uniqueness, that you're a unique person, and that's it. So from a conceptual perspective, are there other ways that are a bit less dystopian and more non-dependent to our corporations, how we can prove our pride, but prove our uniqueness or like humanness? I'd say yes. There are like various other methods, and you can like label them into 3 different categories. One is like biometric centric, where you can use like other parts of the body, or you could use even the picture of yours and resemblance with a certain threshold and the algorithm. You can use another type of identifier that is more like social graph attestation, where these people can attest that, PGP, that I'm a human and I can reuse that as a proof. And there are like third one, which is like you can even rely on your passport. Just take your passport, there's a microchip in it, you can tap a phone, extract the data, there's a certificate, there's a signature from the government, and just prove who you are without revealing anything out of this document. Each of them has its plus and minuses in terms of accuracy. We've seen like WorldCoin really driving this narrative that this is like the most accuracy-driven iris scan that can only be done through the hardware. But apart from like all this math and promises, what worries me, and I'm not gonna like show the fingers. What worries me is that if we're building an identity systems, and if we're really saying that there should be a world that is not solely taken care by the government, being your attester and issuer, we need the system outside of that world. This system has to be censorship resistant. That's like #1 priority, because Bitcoin without its decentralization, meaning no ability for anyone to go after it and ban it, is the reason it survived and we all are sitting here with all the positivities and negativities. Same with identity systems. So it doesn't matter what you scan. If there is a world where any government on every jurisdiction can ban you from operating, and you're dependent on a specialized hardware, even with NPCs and stuff, and then you bind it, all the wallets and all the management of the sovereign money to your identity, and suddenly it's not legal anymore to operate in that country. What we do then? What we do? So it's not the future. I kind of see it scaling up, and that's why going back, I will repeat, it's super important for identity systems to be as sovereign as we have the crypto and initially the Bitcoin ethos that started all that. So much.
Yeah, so I just happen to be a medical doctor, very long while ago. So what I need to say is, while biometric scan of your retina, while valid, if you have any diseases, say diabetes mellitus, right, your scan will change. So what happens then? So am I going to be just, thrown out of the system because I have some disease?
You get another airdrop.
That's the best panel. All right, so let's get back to the serious things, okay? So, Abhishai.
Why?
Yes, we have to. We have to. So, thinking about what you said earlier, and hearing lots of voices in the community saying that there's something to convergence. So, can you actually use one method of encryption, such as Grappled Circuit, or such as ZKs, or such as fully homomorphic encryption? Or should you try to build a more optimized method using several of them? Well, what's your take? Because we know a few projects that are combining, right? We know even Phoenix, FHE, they're going to combine and use some MPC. We know that ICA is also mixing, right? So what's your take?
Yeah, so ICA is meant for signatures, the TSS that I mentioned, not for general computation. Phoenix is for general computation. And what I think is that when you try to solve a problem related to MPC, then you need to pick first the technology that you're going to rely on the most. After you solve it in one way, try to improve using different technology, because it's already really hard to solve it, a general purpose computation with privacy with one technology, and combining different technologies makes it much harder. And there are some companies that tried to do this, and like what I'm seeing them doing now is kind of being moved from actually solving the problem into try to orchestrating other solutions. So one of them is Nilion, for example, Inco as well. So they began by choosing one technology, then they started to explore different technologies, and after some time, because they were not sure about what is the best one, then decided to instead of building one, try to combine other solutions that other people are building, which is I think is simpler. Then I think that in the future we will see some combination of technologies. As you mentioned, Phoenix is using other approaches like secret sharing to solve their threshold decryption part. We are also using some secret sharing in some specific parts of the protocol. But yeah, in the end, the different types of technologies will be combined in one way or another.
It's all very case specific.
Yeah.
Yeah. So we have to wrap it up, but I will ask you for one last blitz question, just really one sentence. We'll start with Lasha.
Okay.
The future. Give us one sentence on what you see in this field in the future.
AI.
Nice. It's really good. Anish, do you have anything left to add?
I'll quote Neil Stephenson. He said, "The future is already there. It's unevenly distributed."
Unevenly distributed. So AI unevenly distributed. Abhishai, what comes to mind?
I think I'll combine both.
All right. I'll encrypt everything they just said. All right. Thank you all so much for joining us today. It was a really good discussion. I think we will have to do one more because I see that there's some good insights coming out of here. So next event, we'll do it again. All right. Thank you.
Thank you.
Thank you to the audience. Cheers.